All right, this is concept development for Module 6, Lesson 14. If you have your little triangle, bring it back. If you have a straight edge, some sort of straight edge to help you draw straight lines. Remember our objective today is to construct parallel line segments and then analyze the relationships between the coordinates. Okay, so we're going to start off with, here's a point. Point A is going to be situated at 2, 3, and point B is going to be situated at 0.75. Go ahead and plot those points and connect them and label that line AB. Okay, go ahead and check back to see if you were able to successfully, is this what you ended up with? And have you gotten used to labeling your x-axis, y-axis, and origin as just something you do? Did you figure out what your coordinate plane, what intervals it was traveling in, it was increasing by as well? Now, what I want you to do is I want you to create a right triangle using this line. Can you see it? Now, do you see it as AB, as the longest side of your right triangle? Well, I see one that is 5 units long and 2 units in height. I see that it could have 2 acute angles. All right, so draw that out. You might have drawn it this direction. You may have drawn it the other direction. So it has 2 acute angles. Acute means less than 90 degrees, right? The bottom left angle is less than the top angle because the triangle is going across more than it is going up. So it's going across more than it's going up. Now find, if you've got your little triangle, pull it out. And remember we labeled it TRS. Okay, now what I want you to do is take your triangle and I want you to draw a line segment parallel to line B. So what are you going to do? How would you move your triangle now in order to create a parallel line to AB? Well, you could slide TRS to the right? You could slide it 1 unit over. You could slide it 2 units over. You could slide it 3 units over, and those would all be parallel, correct? So you can just move the triangle along the grid lines. You could go up, down, you could go to the left, you could go to the right, or a combination of horizontal and vertical movements would be totally acceptable, wouldn't it? It's like what we did in our fluency practice. So LS, let me label this on this side, S, T, R. Let me label it going this direction. At angle S is the same as angle A, right? Coming off the same baseline. So the lines will be parallel. So you can slide triangle RST along the grid lines in a variety of directions and then trace line ST to make a parallel segment, correct? So let's come on back, bring it on back right here where we first drew AB. Now slide your triangle RST to the right 1 full grid space. Is ST parallel to AB? Yes. So what coordinates then does the vertex of angle S touch now? So it's going to touch now 3, 3. Now the vertex of T would now touch what? 6, 7, 8, 8, 5. So how the x-coordinate of the endpoints change, how did they change when I slid the triangle 1 unit to the right? So let's draw this. Let's draw our parallel line. And let's label, okay, and then let's draw, here's our triangle again. And then we're going to label this T, and we're going to label this S. So now this A went from being 2, 3 to then what? 3, 3. That is angle S, right? Then our B, when we slid it over, it became 8, 5. Right? Okay. So what relationship? So this is the crux. This is the big idea of our lesson today. So what happened to our x coordinates? Well, our x coordinates increased by 1, correct? It went from 2 to 3 and 7 to 8 because we kept it in the same coordinate space right here. We didn't move it up and down. We just left it on the same. We left it at 3. All right. My question, did the y coordinates of the endpoints change? No. So as triangle RST slides 1 unit to the right, the x coordinate of the vertices increased by 1. So how can you say in words how the x coordinate would change if the triangle was slid along the grid lines 2 points to the left? What would happen to my grid points then? One, 2. Well, both x coordinates would be 2 less. It's subtracting 2 from the x coordinates. So if we moved it in this direction, we'd be subtracting. When we're moving in this direction, we're adding, right? So let's put our triangle RTS right back here. And I'm going to now slide up along the grid lines 2 units. I'm going to slide up 1, 2. Okay, so I created another parallel line. So is ST, so here I'm going to call this ST here. Is ST parallel to AB? Well, how do you know? Well, you kept the base parallel to the x-axis while you were sliding up. You slid it like there was a ruler on the right that is almost like perpendicular, right? You slid it straight up to the x-axis, and you kept the triangle up against the whole triangle up against it the whole time. So what coordinates does the vertex angle S touch? Well, now it's 2, 5, right? And then what's the vertex of T? It's now 7, 6, 7, 8. It's now 7, 7. So, can you explain how, in your own words, how the y coordinate of the vertices changed when I slid the triangle along the grid lines 2 units up? So did the x coordinates of the vertices change? So did the x's change? No, they did not change because triangle TRST slides up 2 units up parallel to the y-axis. The y coordinates have actually increased. Correct? All right. So hopefully you're understanding how as you slide up on your parallel lines, how it depending on the direction that you slide, if you slide left, right, your x-axis is going to change. Your point on your x-axis is going to change. If you go up or down, your y-coordinate on your y-axis would change. All right. So if you want to play with that again and you want to slide down this time, you can. If you want to slide more to the right, if you want to slide more to the left, go ahead and try that as well. So now we're going to take this and move our triangle right back here to its original location and slide your triangle 2 units to the right and 1 unit down. So here you're going to go 1, 2, and move it down 1. So can you tell how the coordinates of the vertices S and T have changed? So let's draw this out. Here's S now. Here's T now. Yep. Now, trace ST on your plane. We did it. Label the endpoints of your segment as ST. So we're going to push this off to the side. And I want you to be able to label the coordinates of S and T. What is the coordinate pair for the new ST? Can you do it? It should be 4, 2. And T is going to be 9, 4. Question, are they parallel? How do you know? Explain it to yourself. Tell yourself right now how you know. Are they parallel? Yes. So is AB and ST parallel? Well, they're not perpendicular, right? They're not perpendicular, but they would be parallel. They never touch, so they're parallel. When we slide the triangle down, we can think about a parallel imaginary segment. Then when we slide it over, we find a third segment that's parallel to the imaginary one, and then we draw it, right? We moved it over, which was parallel, and then we moved it down. All right. So AB and ST are parallel, and you could go AB is parallel to ST. ST. It's just one line. That's how you signify that something, this is how you document that. So AB and ST are parallel to each other because they are both parallel to the imaginary segment we found when we first slid the triangle down, like when we slid it down. They are both parallel to the imaginary segment. We can also think or talk about the angles in the triangles. So angle A and angle S are the same measure because they were drawn from parallel baselines. So because they're from parallel baselines, we know they're going to be they're going to have the same angle. We use the same baseline from here to here, so we know they're going to have the same angle. So this is how you document it again. Now, compare the coordinates from points A and B to the coordinates of points S and T. Can you say to yourself, can you say it, why each coordinate in point S and T are 2 more than the x coordinates of AB? Well, we shifted the triangle to the right, so the x coordinate increased. Then we slid the triangle right. So we slid the triangle over 2 units along the grid lines. So both x coordinates are 2 more. So, but my question for you now is, why is the y coordinate 1 less? Do you know why? Well, we shifted the triangle down, so the y coordinate actually decreased. We slid the triangle 1 grid square down, so both y coordinates are 1 less. Yes? All right, moving on to the next part. So we are now working with this coordinate grid, this coordinate plane. So now I'm going to write C is equal to 1.5 and 2.5, and then D is going to be equal to 3, 2. Use your straight edge. I want you to plot point C. I want you to plot point D, and then I want you to use your straight edge to connect CD. Okay. Do that and come right back and check to make sure you did it well. All right, is this what you ended up with? Did you just by habit now label your X and Y axis? Did you label the origin? Did you start labeling and figuring out what the intervals in your coordinate plane are? Then did you plot your points and connect line segment CD? Now, I want you to try to envision a right triangle that has CD as its longest side, and its right angle is going to be at 1.5 and 2. So its right angle is going to be at 1.5 and 2. Can you find it, and can you complete the right triangle? Try that and come on back and check. All right, is this what you ended up with? All right, I see a triangle with a height of 1 unit and a length of 3 units. The right angle is to the left 1 unit beneath C, right here. Focus for a moment on the vertex of the triangle that is at point C. Now, visualize the triangle moving to 2 grid units to the left, so if it moved 2 grid units to the left, so remember it'd be this guy right here now, right? So what is the location of the new vertex? So if it moved 2 grid units to the left, plot that, plot it over 1, 2. So now, so how many units down? 1, 2, 3, right? 1, 2, 3 would now be your new triangle, right? Now, I want you to plot point E at 1/2 and 2.5. And then I want you to plot a point F but I want you to first plot point E, 1/2 and 2.5. So 1/2 and 2.5. So, okay, so that's going to be our point E. Now I want you to plot point F on the plane that when connected to E will create a segment that is parallel to CD. So it's going to be parallel. It's moving along here. It's going to be parallel to CD. Remember, it can only be 3 units long. Oops, it has to be along here. And this is your F right here, not here. Okay. So it looks like point C slid 2 units to the left, so I can slide point D 2 units to the left also. So I slid this 2 units. Oh, look, there's F. It's 2 units, there's E. If I think that of the triangle I saw with CD, I can go down 1 unit from E and then find the right 3 units, right? Right here. That will be if point F. So the x-coordinates of E is 1 less than C. So the x-coordinates of E is going to be 1 unit because they're 1/2 units, right? So 1/2 and 1/2. So that'd be 1 full unit, 1 less than C. So I can subtract 1 from D to find the x-coordinate of F. So now name the location of point F. It's going to be at 2, 2. This was at 3 and 2. This was at 1.5 and 2.5. Now E is going to be 1/2 and 2.5. Right? All right. So this is 2, 2. This is 1/2 and 2.5. So now I want you to draw the line. If you haven't already done so, connect E and F together. Now, imagine that the lines from that contain CD and EF, if the part of these lines that we have drawn here are parallel to each other, we can say that the lines that contain them are also parallel. So we're going to write this statement naming the relationship between these 2 lines. Remember, that's our objective today. So this is how we name it. CD is parallel to EF. Now, what if I asked you to plot the point G on the line, and I want you to plot it at 3.5 and 2.5? So plot that point. Where does that end up? So 3.5 and 2.5 right here. That is going to be point G. Now, compare the coordinates of C to point G. So C, so this was 3.5 and 2.5. So if we're comparing point C to point G, what do we know about the X coordinates? Well, this is 2 full units bigger. So a half plus a half is 1. A half is 1.5 plus another half is 2. So it's 2 full units greater on the X for the X, but the Y remains the same. So name the location of a point H. So now I want you to think of point H that when connected to G would create a segment parallel to CD. So now I want you to come up with something that would be parallel. And you're going to, so it's going to be the same distance. So create that line and see what you come up with. All right, so did you end up with something like this? Now, what would you say? What are the new coordinates? Here, it would be 5, 2, right? So it went from 2. Now, what if you wanted to connect it and keep this line going? Where would that go? Kind of explore this for a second. Think about this. Where would this line continue up towards? It would continue up like this. So it would end up being 2, 3, could be another point on that. So if I was continuing this up, 1, 2, 3, and then if we continued that up from here, 1, 2, 3. Do you see it? Here, it's 1 down, 3 across. Look here. 1 down, 3 across. Look at this. 1 down, 3 across. Do you see it? Let me do it again. 1 down, 3 across. 1 down, 3 across. 1 down, 3 across. Do you see that? It's all parallel and they're the same angles. Now, what is the relationship to all of this? Well, this point GH is going to be parallel to CD. GH is parallel to CD. All right, that's essentially what we're doing in our problem set. You're looking for the relationships in our coordinate plane. You're looking for the relationships and how the numbers increase or decrease. So this would be the X or X-axis increasing or decreasing. This is the Y-axis increasing or decreasing. Yes? All right. For problem set, you're going to use the coordinate plane below to complete the tasks, just like we did in our concept development. Problem 1. Problem 2. There is your exit ticket, and here are 2 problems for homework. I'm sure you will be very successful.